Tonight on Zzzcience, we'll drift together into the quiet corners of the universe. Whether your mind is racing or your body just needs rest, these gentle stories of science are here to help you slow down and drift off with ease. This journey takes us beneath our feet to a world that seems still but is never truly at rest. The topic is the restless Earth, a planet whose surface is forever shifting, drifting, and colliding in a dance so slow we hardly notice. Yet so powerful, it has shaped every mountain, every ocean, and every valley we know. Before we drift any further, I would love to know where in the world you are watching from, and what time of night or morning it is for you. It is always a wonder to imagine this shared experience stretching across time zones and continents. If you enjoy these quiet explorations, a gentle tap on the like button helps the channel more than you might think. If you are already subscribed, thank you for joining this sleepy little community. And if not, feel free to subscribe and click the bell so you don't miss the next calm voyage into science.now. I should probably warn you, I hope this video is not so interesting that it keeps you wide awake. But if it does, then at least you will come away with some surprising knowledge to carry with you into tomorrow. So, settle in, let the outside world soften, and let the story begin. Have you ever wondered what secret motions are happening deep beneath the ground you walk on every day? The earth may feel solid and still beneath your feet, but in truth, it is a restless traveler. Its surface is made of giant slabs, tectonic plates that drift slowly but ceaselessly, reshaping the planet as they move. These drifting pieces of Earth's crust are older than any human civilization, and yet they are as alive with motion as the waves of the sea. In this calm exploration, we will unfold the story of these plates, how they were discovered, how they move, and how they have carved the face of the world. This is a tale of fire rising from the mantle, of continents pulling apart and colliding, of oceans born and mountains raised. It is also the story of how the hidden movements beneath us shape climate, guide the path of evolution, and even influence the myths that humans tell to explain trembling ground. The beauty of plate tectonics is not only in the science, but in its patience. While our lives play out in days and years, the Earth moves in spans of millions of years, quietly sculpting landscapes we take for granted. Tonight, we will let those timescales stretch out before us, moving as slowly and steadily as the Earth itself, pausing where the science is curious and lingering where the imagination can take comfort. The restless Earth is not something to fear, but something to marvel at. It reminds us that even in silence and stillness, the world is alive with motion. As you drift further into this story, let the thought of mountains rising, seas opening, and continents wandering be a quiet companion to your own journey into rest. In the beginning, Earth was a place of fire. Imagine a young planet, still glowing with the heat of its own birth. A ball of molten rock circling a young sun in a solar system full of chaos. Asteroids and comets crashed down with relentless fury, stirring the surface and keeping it in a state of liquid turmoil. To stand there, if one somehow could, would be to witness a world in the making. A world too hot for oceans, too violent for life, and yet full of the raw materials that would one day build mountains, forests, and even ourselves. The planet formed about 4 billion years ago, from the swirling dust and gas left over after the sun ignited. Gravity pulled this debris together bit by bit until clumps of rock collided and fused, growing into something large enough to be called a world. Those collisions were not gentle. Each impact released colossal amounts of heat, enough to keep the entire planet glowing red. Like a furnace without end, heavier materials such as iron and nickel sank inward toward the core, while lighter rocks floated upward, eventually becoming what we now call the crust. Slowly, as the bombardment lessened, Earth began to cool. The surface hardened in patches, though molten rivers of lava still cut across it. This early crust was fragile, constantly broken apart and remade. It was more like a cracked skin than a stable surface. Beneath it, the mantle churned with heat, and above it, the thin beginnings of an atmosphere took shape. Not one you would ever want to breathe. Instead of oxygen, it was thick with carbon dioxide, methane, and ammonia. The byproducts of volcanic eruptions that sent plumes of gas spilling into the sky. Lightning crackled through this toxic haze, striking down into pools of lava and boiling seas. And yes, there were seas. For all the fire, there was water. Some of it came from volcanic steam that condensed into rain, falling for millions of years until it collected in low basins. Some of it was delivered by icy comets that struck Earth and melted away, leaving behind vast amounts of liquid water. Together, these sources filled the first oceans, perhaps shallow at first, but spreading wider and deeper as time went on. To imagine those first rains is to picture clouds that never parted, sheets of water falling onto a world still trembling with heat, hissing as it struck the half-cooled crust. Out of this meeting of fire and water, the surface of Earth slowly settled into something recognizable as a planet rather than a cosmic battleground. With oceans came change. Water softened the land, carving channels, breaking apart rocks, and carrying minerals back to the sea. Chemistry began to stir in ways that would one day lead to life, though that was still far in the future. For now, Earth was an infant world, covered by volcanic islands, restless seas, and skies filled with storms. The continents we know did not yet exist, but their foundations were forming. Blocks of lighter rock rising above the heavier oceanic crust, like rafts on a molten sea. If one could look from space at that time, the Earth would have appeared very different from today. There were no wide continents stretching across the globe. Instead, there were clusters of rocky fragments shifting and colliding, merging into larger landmasses. It was a restless puzzle still being put together. These early movements hinted at the drifting of continents that would one day become the slow heartbeat of geology. The crust was not a single solid piece, but a mosaic of parts, nudged and jostled by forces deep inside the planet. This was the beginning of something extraordinary. The restless nature of Earth itself, unlike Mars with its quiet frozen surface, or Mercury locked in silence near the sun, Earth was set apart by its ability to change. The crust was thin enough to crack, the mantle hot enough to flow, and the core powerful enough to drive motion for billions of years. These conditions ensured that our planet would never remain still. Mountains would rise, oceans would open, and land would wander. The young Earth was both hostile and generous. Hostile because of the endless volcanic eruptions, the poisonous air, and the meteor strikes that scarred its surface. Generous because within this chaos, it forged the elements of a stable crust, the waters of oceans, and the air that would slowly shift toward supporting life. It was a world finding balance, though balance in geology is never still. It is a balance of moving parts, of stone and water trading places, of heat and pressure locked in a dance. Even the moon played its part. Born from a colossal collision with a Mars-sized body, the moon's gravity helped steady Earth's tilt, calming what might have been a wildly unpredictable spin. Tides began to move in the young oceans, pulling water back and forth, shaping shorelines and stirring chemical reactions. In this way, even the heavens contributed to the restless story of Earth. When we look at the ground beneath us now, it can feel immovable, ancient and eternal. But the first hints of continental drift remind us that this is an illusion. Beneath the stillness lies motion. The continents may move only a few centimeters each year, slower than your fingernails grow, but over millions of years, that is enough to reshape everything. The mountains, valleys, and seas we see today are the end result of that first fiery beginning, when Earth decided it would never be truly still. The story of fire and stone is the story of a planet that cooled just enough to harden, but never enough to fall silent. A place where oceans gathered, where the crust cracked and shifted, and where the seeds of continental drift were first planted. It is a reminder that even in the slowest processes, in the quietest shifts, there is power beyond measure. The young Earth may be long gone, but the restlessness it began still hums beneath our feet, guiding the shape of the world we live on. At the dawn of the 20th century, the world seemed neatly mapped and understood. Continents were drawn, oceans named, mountains catalogued. The Earth, people thought, was solid and still, its great land masses fixed in place for all of history. Yet one man looked at those maps and saw something others overlooked. Alfred Wegener, a German meteorologist with a curious mind, noticed that the continents seemed to fit together like pieces of an ancient puzzle. South America's eastern coastline curved neatly into the bulge of Western Africa. It looked less like coincidence and more like evidence of something deeper. Wegener began to wonder, what if the continents had once been joined together? What if they had drifted apart, carried across the surface of the Earth by some unknown force? This idea, bold and strange for its time, would become known as the theory of continental drift. It was not the first time someone had suggested the continents might have moved, but Wegener was the one who gathered the evidence and gave the idea structure. He collected fossils that told a curious story. Identical species of plants and animals, long extinct, were found on continents now separated by vast oceans. How could a tiny reptile from the Permian period called Mesosaurus appear in both South America and Southern Africa unless those continents had once been connected? He looked at ancient rocks and mountain ranges which seemed to line up perfectly when the continents were reassembled. He even studied ancient climates, pointing out that evidence of glacial deposits in India, Africa, and South America made sense only if those lands had once been close to the South Pole. The picture was convincing to him. Wegener proposed that all the continents had once been united in a single supercontinent he called Pangaea, meaning all Earth. Over millions of years, he said, this massive landmass had split apart, with pieces drifting slowly to their present positions. It was a daring thought. The problem was, Wegener could not explain how such a monumental drift was possible. What force could shove entire continents around? His answer, vague at best, was that the continents plowed through the oceanic crust like icebergs through water. Geologists were unimpressed. To them, the Earth's crust was solid and immovable. The idea of continents wandering across the globe sounded absurd, more fantasy than science. Wegener's theory was ridiculed, dismissed as the dream of a man who studied weather, not rocks. At conferences, he was treated with skepticism, sometimes with open laughter. One American geologist declared that Wegener's theory was utter damn rot. Another quipped that if the continents really did drift, the force pushing them would be the wrath of Almighty God. It did not help that Wegener's timing was poor. In the early 20th century, geology was built upon the assumption of a static Earth. Mountains were thought to rise from the planet shrinking as it cooled, like wrinkles forming on a drying apple. Oceans were considered permanent fixtures. To challenge these foundations was to challenge the very identity of the field. Wegener's critics were not just protecting ideas, they were protecting the pride of a discipline. And yet, Wegener's evidence lingered. The fossil trails, the matching rocks, the puzzle piece continents, they did not go away simply because people ignored them. The seeds of his idea lay dormant, waiting for a new generation of discoveries to bring them to life. Wegener himself would never see that happen. He died in 1930 during an expedition to Greenland. His theory still considered a fringe idea, but science, like the Earth itself, is restless, and truth has a way of resurfacing. The turning point came in the mid-20th century, when technology allowed humanity to peer into the depths of the oceans. During and after the Second World War, navies mapped the seafloor in detail for the first time. What they found astonished them. Running down the middle of the Atlantic was a vast mountain chain, thousands of kilometers long, called the Mid-Atlantic Ridge. Similar ridges appeared in other oceans. The seafloor, far from being a flat, lifeless plain, was a landscape of mountains, trenches, and valleys. Even more remarkable were the patterns in the rocks of the seafloor. As scientists studied the magnetic properties of oceanic crust, they discovered something odd. The iron-rich minerals in volcanic rocks aligned with Earth's magnetic field when the rock solidified. But Earth's magnetic field had flipped many times in the past, north becoming south and then back again. The seafloor recorded these flips as stripes of alternating polarity, running parallel to the ridges. Each stripe was a magnetic memory frozen into stone. This striped pattern revealed something extraordinary. New crust was forming at the ridges, pushing outward as molten rock rose and cooled. The seafloor was spreading, carrying the continents with it like passengers on a slow-moving conveyor belt. Suddenly, Wegener's drifting countenance made sense. They were not plowing through solid crust. They were riding on slabs of rock created and destroyed by deep earth. Processes. The pieces came together in the 1960s as the theory of plate tectonics emerged. Wegener's once ridiculed idea was reborn, now with the physics and mechanics to back it up. The continents did drift, but they were part of larger plates moving on the restless mantle beneath them. Mountains, earthquakes, volcanoes, and ocean basins could all be explained through this framework. What once seemed laughable became the cornerstone of modern geology. Looking back, it is easy to wonder how so many scientists missed what now feels obvious. But that is the nature of discovery. Ideas too bold for one generation can become the foundations of the next. Wegener was not alive to see the vindication of his work, but his legacy is carved into every geology textbook and every map of tectonic plates. His vision of a dynamic Earth, shifting and changing, opened the door to a new way of understanding the planet. There is something poetic in this story. A man staring at maps dared to imagine the continents wandering across time. His peers laughed, but the Earth itself had the last word, whispering its truth through magnetic stripes on the ocean floor. Today, as we stand on what feels like solid ground, we know it is anything but. Beneath our feet lies motion, proven not by imagination alone, but by the hidden patterns of stone, recorded patiently over millions of years. The invention of plate tectonics was not a single spark, but a slow gathering of evidence. the gradual turning of skepticism into acceptance. It reminds us that science is never finished. What we dismiss today may be tomorrow's truth, waiting quietly beneath the surface until we are ready to listen. Just as the continents drift, so too does human understanding, carried along by curiosity and time. Beneath your feet lies a puzzle, so vast and so slow-moving that it takes the span of millions of years for a single piece to slide into place. The surface of Earth, which feels so solid and unshakable, is in truth a mosaic of plates. Imagine the planet as a cracked eggshell, though one that is constantly being reshuffled by heat from within. These fragments are the tectonic plates, and together they form the restless skin of our world. There are 7 giant plates that dominate the surface. The African plate stretches across deserts and jungles, carrying the vast continent and pushing into the Atlantic Ocean. The North American plate holds not just the continent we know, but also much of the Atlantic seafloor. Its partner to the south, the South American plate, drifts westward toward the Pacific. The Eurasian plate is immense, spanning from the Atlantic all the way across to Asia, locked in a slow-motion dance with its neighbors. Beneath the Pacific itself lies the largest plate of all. The Pacific plate, a slab of rock so vast it covers nearly 1/3 of Earth's surface. Then there is the Antarctic plate circling in icy solitude, and the Indo-Australian plate, which some geologists divide into 2, the Indian and Australian plates, each playing their part in mountain building and ocean spreading. But the story does not end with these 7. Around their edges clustered smaller plates, fragments and slivers caught in the grinding gears of geology. The Nazca plate off the west coast of South America, the Cocos plate near Central America, the Philippine Sea plate, the Caribbean plate. These and many more remind us that the planet is not neatly divided into just a handful of pieces. It is a living puzzle with dozens of parts, some large enough to carry whole continents, others just shards slipping between giants. What makes this puzzle extraordinary is not just that the pieces exist, but that they are always on the move. Each plate drifts a few centimeters every year, carried by the slow churning of the mantle below. Over human lifetimes that motion is imperceptible, but over geological time it adds up to the shifting of entire oceans and the birth of towering mountain ranges. The edges of the plates are where the drama unfolds. Far from being quiet, it seems, these boundaries are zones of creation, destruction, and transformation. There are 3 main kinds of edges, each with its own character. At divergent boundaries, plates move apart. Here new crust is born as molten rock wells up from below, hardening into ridges that stretch across the ocean floor. The Mid-Atlantic Ridge is the most famous example, a scar running down the middle of the Atlantic Ocean, where Europe and Africa slowly drift away from the Americas. It is hard to imagine an entire ocean widening before our eyes. Yet each year, the Atlantic grows just a little wider, its edges pulled apart by this invisible force. Then there are convergent boundaries, the great collisions of geology. At these edges, plates push against one another, and something must give. Often the denser oceanic plate sinks beneath its lighter continental partner, plunging into the mantle in a process called subduction. This recycling of crust fuels chains of volcanoes, like those that ring the Pacific in a fiery horseshoe. In other cases, when 2 continents collide, neither is willing to sink. Instead, the land crumples upward, forming mountain ranges that seem to defy time itself. The Himalayas, the tallest mountains on Earth, are the direct result of the Indian plate pressing into Asia, a collision that continues to this day. The third type of boundary is transform, where plates slide past each other. There is no creation or destruction of crust here, only grinding motion. These edges are notorious for earthquakes as stress builds along faults until it is released in sudden jolts. The San Andreas Fault in California is perhaps the most famous example, where the Pacific plate slides northward past the North American plate, carrying Los Angeles ever closer to San Francisco, though only at the pace of a fingernail's growth each year. Each boundary type has its own story to tell. Divergent zones create, convergent zones destroy, and transform zones shuffle. Yet together they form a balanced system, a restless cycle of renewal and change. Without them, the surface of Earth would be stagnant, lifeless, a silent shell like the crust of the moon. Instead, the puzzle pieces grind, stretch, and collide, giving rise to earthquakes, volcanoes, and mountains, and keeping the planet's surface young and ever-changing. It is at the boundaries that we see the pulse of the Earth most clearly. Along mid-ocean ridges, black smokers belch superheated water into the deep, feeding ecosystems that thrive without sunlight. Along subduction zones, deep-sea trenches mark the descent of crust into the abyss, while arcs of volcanoes rise above, their eruptions both destructive and creative. Along transform faults, cities tremble as the hidden stresses of geology are released in an instant. These edges remind us that the Earth beneath our feet is not a passive stage, but an active participant in the story of life. The great puzzle of tectonic plates is one of the most elegant discoveries in science. It unites seemingly separate phenomena, earthquakes, volcanoes, mountain ranges, and ocean trenches into a single interconnected framework. What once looked like unrelated mysteries are now understood as different expressions of the same underlying restlessness. To picture Earth's surface as a puzzle is to appreciate its complexity. Each piece is distinct, yet none can move without affecting its neighbors. The Pacific plate collides with South America, raising the Andes. The African plate splits apart in East Africa, birthing a new ocean in the making. The Antarctic plate spins quietly at the bottom of the world, edged by a necklace of spreading ridges. Every boundary tells a story, and together they write the history of our planet. And yet, despite how much we know, there remains something mysterious in this puzzle. The plates are vast beyond comprehension, moving with patience that defies human timescales. To us, the ground is steady, but to the Earth, it is in constant flux. The restless boundaries where the action happens are invisible most of the time, hidden beneath oceans or buried beneath mountains, yet they shape every landscape we see. It is easy to think of puzzles as something finished once all the pieces are placed. But Earth's puzzle has no final picture. It is a work in progress, endlessly rearranged. Never complete, the pieces slide and grind, split and collide, creating new shapes and erasing old ones. The puzzle beneath us is alive, and in its slow, ceaseless shifting, it reminds us that nothing on Earth is truly fixed, not even the ground we stand on. Deep beneath the crust, far below the continents and oceans, lies the true engine of Earth's restlessness. To the human eye, the mantle is hidden, invisible, a place of silence. Yet in reality, it is anything but silent. It is a slow, swirling ocean of rock, not liquid exactly, but soft enough under pressure and heat to flow like warm wax. This vast mantle, stretching nearly 3,000 kilometers from crust to core, is what keeps the plates above in motion. Without it, Earth would be still, a cold and lifeless shell. The mantle is heated from below by the core, where temperatures rival the surface of the sun. That heat does not stay put. It rises upward in giant currents, just as steam lifts from a boiling pot, or warm air drifts toward the ceiling. Rock in the mantle behaves the same way, though at a speed that would make glaciers look quick. Hot material slowly rises, cooler material sinks, and this convection sets the surface drifting like rafts on a sluggish tide. It is strange to think that something as solid seeming as stone could move in such a way. But under immense pressure and at extreme temperatures, rock is not rigid. It creeps, stretches, and bends. Over millions of years, it behaves more like a thick liquid than a brittle solid. Imagine honey left in a jar on a warm day, barely flowing, yet never truly still. This is the mantle, patient, powerful, and endlessly stirring. From these currents arise plumes, narrow upwellings of superheated material that punch their way through the mantle and into the crust above. When one of these plumes reaches the surface, it creates hotspots, fixed points of volcanic activity that burn through moving plates. The Hawaiian Islands are a perfect example. As the Pacific Plate drifts northwest, the hotspot stays put, creating a trail of volcanoes that form a chain across the ocean. Each island is a marker of where the plate once sat above the plume, like footprints in stone across geological time. Other plumes have reshaped entire continents. The vast lava fields of India, known as the Deccan Traps, were created by a hotspot eruption so immense it may have contributed to the extinction of the dinosaurs. In Iceland, a hotspot rising beneath the mid-Atlantic ridge fuels constant volcanic activity, splitting the island in two, even as new crust is born beneath it. These fiery anomalies remind us that the mantle is not uniform. It is a restless sea, dotted with rising plumes and sinking slabs, each one stirring the great pot of earth. The mantle also acts as a conveyor belt for crust. At mid-ocean ridges, molten rock wells up and hardens into new seafloor. This fresh crust is pushed outward, sliding away from the ridge as more material takes its place at subduction zones. The conveyor turns downward, pulling old crust into the depths to be melted and recycled. The plates ride this cycle endlessly, created, carried, and destroyed by the currents below. It is a system that has run for billions of years, and without it, our planet would look nothing like it does today. Why, though, does this conveyor belt move so slowly? Plates drift at just a few centimeters a year, a pace almost comically sluggish. The answer lies in the sheer scale of the forces involved. The mantle is vast, and its currents operate on timescales far beyond our perception. The heat from the core rises steadily but not quickly, and the rocks of the mantle, though soft under pressure, are still resistant. It is as though an entire planet is caught in a slow-motion tug of war, with gravity, heat, and pressure all playing their part. Yet over time, those few centimeters add up. In a single human lifetime, a plate might shift only the width of your hand. But across 1,000,000 years, it moves tens of kilometers. Across hundreds of millions, oceans open, mountains rise, and continents drift from pole to pole. What feels to us like stillness is to the Earth the steady heartbeat, each pulse carrying the surface into a new arrangement. The deep engine is not uniform or predictable. Sometimes it speeds up, sometimes it slows. Slabs of cold crust sinking into the mantle can drag plates more quickly, while plumes of hot rock can force sudden bursts of volcanic activity. In some places, the mantle may even split into complex patterns of swirling flow, creating hotspots in unexpected locations. Though scientists have mapped much of the mantle using seismic waves, much remains mysterious. It is a hidden world, glimpsed only through vibrations and the clues left. Behind on the surface, there is something almost poetic about the way this engine works. Heat from Earth's fiery heart rises, cools, and sinks, creating a cycle that has no end. From this endless stirring comes the movement of continents, the birth of oceans, and the rise of mountains. The mantle is like the unseen breath of the planet, exhaled slowly through volcanoes, inhaled again as crust sinks back into the deep. For all its power, the deep engine is also fragile in its balance. Too much heat and the crust would be torn apart too quickly. Too little and the planet would stagnate, its surface frozen in silence. Our Earth exists in the sweet spot, restless enough to renew itself, steady enough to sustain life. It is this delicate balance that has allowed oceans to cycle, climates to shift, and life to flourish. When you stand on the ground and feel the illusion of stillness, remember that far beneath you, the mantle churns like an eternal tide. It pushes the continents together and pulls them apart. It builds mountains and opens seas. It is the unseen hand that writes the history of Earth, centimeter by centimeter, year by year. Without pause or rest, the slow drift of plates may seem trivial compared to the speed of our daily lives. But without that drift, there would be no Himalayas, no Pacific Ring of Fire, no Atlantic Ocean stretching wide. The deep engine ensures that Earth is not a static sphere, but a living, breathing world. And though it moves at the pace of eternity, its influence shapes every landscape, every coastline, and every horizon we see. The restless Earth begins in silence deep below, in the dark currents of the mantle. It is there that the story of drifting continents and shifting seas takes root. It is there that the patient heat of the core fuels the grand slow dance of the plates. And it is there, hidden from sight, that the engine hums on, reminding us that stillness is never truly still. There are places on Earth where the planet is quietly tearing itself apart. They are not marked with flashing signs or warnings, and most lie hidden beneath the oceans. Yet they are among the most important features of our restless world. These are the divergent boundaries, places where tectonic plates drift away from one another, pulling the crust apart and leaving space for new Earth to be born. It may sound dramatic, but it happens with such calm regularity that our entire planet has been reshaped by it, centimeter by centimeter, ridge by ridge, over hundreds of millions of years. The most famous example lies in the heart of the Atlantic Ocean, stretching like a vast scar from the icy north all the way down to the southern tip of the planet. The Mid-Atlantic Ridge is a mountain chain longer than anything on land. It winds across the seafloor for tens of thousands of kilometers, its peaks hidden beneath waves, its valleys home to creatures that thrive in total darkness. This ridge is no ordinary mountain range. It is a seam, a place where the Atlantic Ocean is opening wider with each passing year. Europe and Africa drift eastward, while the Americas slide away to the west, carried on plates that creep apart at the speed of a fingernail's growth. What makes this ridge remarkable is the process at its heart. Beneath it, molten rock from the mantle rises to fill the gap left by the separating plates. When this molten material cools, it hardens into new crust. In this way, the seafloor is constantly renewed, pushed outward from the ridge like pages on a conveyor belt. The crust near the ridge is young and fresh, while that at the edges of the ocean is ancient, having drifted for hundreds of millions of years before finally meeting its end in a subduction zone. This birth of new crust is not just a geological curiosity. It is the engine that drives the widening of oceans. Without it, there would be no Atlantic as we know it. The land masses of the world would still be locked together in ancient configurations, with no open sea between them. The mid-Atlantic ridge is proof that Earth is never finished, that it is always remaking itself in stone and water, and the ridge is not alone. Similar divergent boundaries crisscross the seafloor in every ocean. The East Pacific Rise, the Indian Ocean Ridge, and countless smaller rifts, all marked places where Earth splits open to create anew. Together, they form a global network of seams, a hidden pattern beneath the waves. The total length of these ridges is greater than all the rivers on Earth combined, yet most of them are unseen, their presence revealed only by sonar maps and seismic activity. Life too has found a way to thrive in these places of rupture. Along the ridges, hydrothermal vents spew superheated water rich in minerals, creating alien ecosystems that survive without sunlight. Giant tube worms, blind shrimp, and strange bacteria gather around these black smokers, drawing energy not from the sun, but from the chemical reactions of the deep. In a way, the tearing of the crust has given birth not only to new seafloor, but also to entire communities of life, sustained by the hidden furnace of the mantle. While most divergent boundaries are concealed beneath oceans, one remarkable rift can be seen on land. In eastern Africa, a great crack is splitting the continent apart. The East African Rift stretches thousands of kilometers from the Red Sea down through Ethiopia, Kenya, Tanzania, and beyond. Here, the African plate is slowly being torn into two, with the smaller Somali plate drifting eastward. Lakes fill the low spots, volcanoes rise along the edges, and the land itself is pulled apart by forces so slow and steady that they can scarcely be felt from one human lifetime to the next. Yet the results are unmistakable. Lake Tanganyika, one of the deepest lakes in the world, lies in a rift valley created by this slow tearing. The Great Rift Valley of Kenya is another visible scar, marked by steep cliffs and fertile plains. Over millions of years, this rift will widen until seawater rushes in and a new ocean is born. One day, the Horn of Africa may be an island, separated from the mainland by a stretch of sea, where now there are only fields, villages, and wild savannas. To imagine such a transformation is to glimpse the patience of the planet. Oceans opening not with a roar, but with a whisper stretched over millennia. These rifts remind us that continents are not eternal fixtures. They are as restless as the oceans, splitting, drifting, and recombining in endless cycles. The land we consider permanent is in reality just one chapter in a story that spans billions of years. Today's valleys and ridges are tomorrow's seas and mountains. The earth writes its history not in ink, but in the slow rearrangement of stone. There is a strange comfort in this process. Though rifts can create earthquakes and volcanoes, their larger story is one of renewal. Divergent boundaries ensure that the planet is never stagnant, that crust is recycled, and that the surface remains dynamic. They are the quiet architects of oceans, the unseen hand that reshapes the map of the world. If you stand on the edge of the East African Rift, you can see the ground opening beneath your feet, though only if you know where to look. The cracks may be small, the shifts imperceptible, yet they tell of a continent in motion. If you could return in 10 million years, you would not find the same landscape. Instead, there would be waves crashing on a new shore, islands scattered across the horizon, and a continent forever changed. The idea that Earth is splitting itself apart may seem unsettling, but it is also profoundly beautiful. The crust is not breaking in anger, but in creation, making room for what comes next. Divergent boundaries remind us that endings and beginnings are often the same thing, that the rupture of today is the birth of tomorrow. And though we may never witness the full transformation with our own eyes, we walk every day on a planet that is quietly, patiently making itself anew. If divergent boundaries are Earth's way of creating new crust, then subduction zones are its way of tidying up. Our planet is a master recycler, never allowing its surface to simply accumulate forever. Instead, the crust is drawn back into the depths, melted, reshaped, and eventually reborn. This process is called subduction, and it is one of the most dramatic, dangerous, and creative forces at work beneath our feet. Subduction begins when two plates meet head-on. Unlike the slow parting of a rift, this is a collision. One plate must yield, and in most cases, it is the denser oceanic crust that dives beneath the lighter continental crust. The descent is not graceful. It is a plunge into the mantle, forming a long scar in the ocean floor known as a trench. These trenches are some of the deepest places on Earth, hidden chasms that make the tallest mountains look small by comparison. The Mariana Trench in the western Pacific sinks nearly 11 kilometers below the surface, so deep that Mount Everest would vanish beneath its waves with room to spare. As the oceanic plate slides downward, it does not disappear quietly. The friction between the sinking slab and the overlying plate generates enormous stress, which is released as earthquakes. Some of the world's most powerful quakes have originated in subduction zones. The devastating event in Japan in 2011, which triggered a massive tsunami, began with a subducting plate jerking beneath the Eurasian plate in Chile. Alaska and Indonesia, similar collisions have unleashed seismic energy felt across oceans. But subduction is not only about destruction. As the oceanic crust descends, it carries with it water and sediments from the seafloor. When these materials reach the mantle, they lower the melting point of the rock, creating pockets of magma. This molten rock rises through the crust, erupting at the surface as volcanoes. The result is a volcanic arc, a chain of fiery mountains that parallels the trench below. The Andes in South America, the Cascades in North America, and the volcanoes of Japan and Indonesia are all born of this process. Together, trenches and volcanic arcs are the signature of subduction. One marks the place where crust sinks, the other where it resurfaces in fire in between. Earthquakes ripple as the plates grind and strain. It is a cycle of removal and renewal, destruction and creation, a geological breathing that has shaped coastlines and mountain ranges for hundreds of millions of years. From a distance, this recycling might seem ruthless. Oceanic plates are born at mid-ocean ridges, live their lives drifting across the seafloor, and eventually meet their fate in a trench. They are pulled downward, transformed by heat and pressure, and melted into the mantle. But it is this very process that prevents Earth from becoming a static, lifeless sphere. By recycling old crust, subduction allows the surface to stay dynamic. Without it, oceans would simply grow larger and larger, continents would pile up without end, and the surface would lose the balance that makes it so alive. the story of subduction can also be traced in the rocks. Ancient volcanic arcs leave behind granite mountain ranges once the volcanoes themselves have eroded away. Traces of long-vanished oceanic plates can be found as thin slices of basalt embedded in mountains. These relics are geological fossils, evidence of oceans that closed and disappeared long before humans appeared. The Himalayas, though born of continental collision rather than classic subduction, contain remnants of an ancient ocean floor now lifted high into the sky. The Alps, too, are stitched with fragments of ocean crust, carried upward as plates collided and recycled. Even the chemistry of our atmosphere owes something to subduction. Volcanoes fueled by descending plates release gases into the air, including carbon dioxide and water vapor. Over time, this exchange between mantle and sky has played a role in regulating climate, influencing ice ages and warm periods. In this way, subduction is not just a local event, but a planetary one, linking the deep Earth to the surface and even to the air we breathe. Yet, despite all we know, subduction still holds mysteries. Scientists debate exactly how it begins. Does a plate simply get too heavy and sink of its own accord? Or must an outside force shove it into the mantle first? And why do some regions host long-lived subduction zones while others remain quiet for eons? These questions remind us that the Earth, for all our study, keeps its secrets close. There is also something humbling about the timescales involved. A plate may take hundreds of millions of years to complete its journey from ridge to trench. The ocean floor beneath your feet today may one day vanish entirely, swallowed by the mantle and reborn somewhere else. In the grand scheme of geology, nothing is permanent. Land and sea trade places, mountains rise and crumble, and crust recycles endlessly in a cycle older than life itself. To stand near a subduction zone, if one could, would be to feel the tension of opposites. Beneath the ocean, a slab of crust slides silently downward, while above it, a line of volcanoes marks its fiery transformation. The ground shudders with earthquakes. The coastline warps and shifts, and new mountains slowly rise. It is a place where the hidden forces of the planet are laid bare, not in sight, but in sound and movement, in the rumble of the Earth's voice. Subduction is Earth's way of keeping balance, of ensuring that creation and destruction remain in harmony. For every kilometer of new crust born at a mid-ocean ridge, another is consumed in a trench. The planet does not grow larger, nor does it shrink. It simply recycles endlessly. The skin of Earth is renewed in fire and folded back into the depths as though the planet itself were breathing in and out, slowly, patiently, across the ages. When we look at a map and see the arcs of volcanoes tracing the Pacific Rim or the deep trenches cutting along the ocean floor, we are seeing only the surface of this process. Beneath lies a world of motion and heat, a cycle that has been at work since the earliest days of the planet. It is a reminder that nothing, not even the ground itself, is permanent. The continents we walk upon are temporary travelers, carried on plates that will one day vanish, replaced by new land in new arrangements. The restless Earth is not careless in its recycling. It is purposeful. Old crust is taken in, broken down, and given back in new form. Mountains rise from ashes, islands emerge from the sea, and the surface is forever remade. Subduction is not an ending, but a transformation, a reminder that even the deepest destruction is also a beginning. The Earth recycles itself endlessly, and in that cycle lies both its mystery and its enduring beauty. when two continents collide, the result is not gentle. It is not the quiet slipping of plates beneath oceans, or the slow stretching of a rift. It is the meeting of equals, each refusing to yield, each too buoyant to sink into the mantle. And when continents lock horns, the earth responds by crumpling and folding, thrusting the crust upward into vast chains of mountains. This process is known as orogene, mountain building, and it is one of the most awe-inspiring consequences of plate tectonics. The most famous example towers over Asia, the Himalayas. These immense peaks are the direct product of a colossal collision that began about 50 million years ago, when the Indian plate slammed into the Eurasian plate. Before that encounter, India had been a separate island continent. Drifting northward across the Tethys Ocean, it moved quickly by geological standards, racing north at nearly 15 centimeters a year. Eventually, the gap closed, the ocean disappeared, and the two continents met with unstoppable force. With neither plate able to subduct, the crust had only one option. It had to go up. The result was the birth of the Himalayas, a mountain range so vast it reshaped not only the land but also the climate of the entire planet. Even today, the collision continues. The Indian plate is still pushing into Asia, and the Himalayas still rise, growing a few millimeters taller each year. For climbers, this means the world's highest peaks, like Everest and K2, are not frozen monuments, but works in progress, slowly climbing toward the sky. For geologists, it is a reminder that mountains are not just remnants of ancient upheaval. They are active, living landscapes, caught in the grip of forces far greater than themselves. But orogene is not limited to Asia. Across the globe, mountain chains tell the stories of past collisions. The Alps formed when the African plate nudged into Europe, folding up rocks and leaving behind a landscape of jagged peaks and valleys. The Appalachians, older and more worn, are the eroded remains of a collision that once rivaled the Himalayas. When North America and Africa joined in the supercontinent Pangaea, though time has softened them into rolling hills, their rocks still whisper of a violent birth long ago. The mechanics of mountain building are varied, but the essence is the same. Immense pressure forces rocks to bend, fold, and fracture. Layers of sedimentary rock that once lay flat at the bottom of ancient seas are shoved skyward, tilted into improbable angles, or even stacked one on top of another in great sheets. Whole sections of crust may thrust forward, like giant wrinkles on the skin of the earth. Over time, erosion shapes these new ranges, rivers cutting deep valleys, glaciers carving ridges, wind and rain smoothing sharp edges into gentler forms. But beneath that sculpting, the upward push continues, keeping mountains alive against the forces that try to wear them down. This balance between uplift and erosion is why mountains can endure for so long. The Himalayas rise as fast as rivers and weather can wear them down. If the collision ceased, the peaks would eventually crumble, ground down to plains over tens of millions of years. But as long as plates continue to collide, the rise and fall remain in balance, and the mountains endure. In this way, the tallest ranges on Earth are both fragile and eternal, always changing, never finished. The collision of continents does more than build mountains. It reshapes climate, diverts rivers, and even influences life itself. The uplift of the Himalayas, for instance, altered wind patterns and monsoon cycles across Asia, creating fertile plains that became home to great civilizations. The erosion of young mountains supplies rivers with sediments, nourishing farmlands downstream. Even global carbon cycles are affected, as fresh rock exposed by uplift reacts with the atmosphere, slowly drawing down carbon dioxide and influencing Earth's long-term climate. Mountains are not just scenery. They are engines of planetary change. The collision of India and Asia is particularly powerful because of its scale. The Indian plate is still moving north, bulldozing its way into Eurasia, and the impact zone stretches thousands of kilometers. Earthquakes ripple through the region, sudden reminders that the collision is far from over. Entire cities sit atop the grinding fault lines created by this slow-motion crash. For the people who live in the shadow of the Himalayas, the mountains are both a source of wonder and a source of danger. Majestic yet restless neighbors that can shake the ground without warning. Yet even as they threaten, mountains inspire. They rise as symbols of endurance, their peaks touching the sky, their valleys sheltering life. Poets, mystics, and travelers have looked to them as places of mystery and transcendence. For climbers, they represent the ultimate challenge. For scientists, they are windows into deep time. Their folded rocks preserve records of vanished oceans and ancient collisions. Each layer of stone is a page in Earth's history, tilted and lifted for all to see. It is curious to think that mountains, which seem so solid, are products of motion. They are monuments to movement, the outcome of continents drifting and colliding. Their grandeur is born not of stillness but of conflict, not of permanence but of ceaseless change. And though they may seem timeless to us, they too will fade. One day the Himalayas will erode, their peaks ground down into sediments carried to the sea, just as the once mighty Appalachians were worn into gentle ridges. But for now they rise, reminding us that the ground beneath us is never still. Why do mountains keep rising even today? Because the forces that created them are ongoing. The plates continue to push. The crust continues to crumple, and the mantle below continues to drive the motion. Mountains are caught in a constant tug of war, uplift pulling upward, erosion dragging downward. For as long as the balance tips toward uplift, the peaks will climb higher, defying gravity in their patient ascent. The story of colliding continents is one of power, patience, and transformation. It is a story written in stone, visible in the jagged skylines of young ranges and the softened hills of old ones. It reminds us that the landscapes we cherish are not fixed backdrops, but active creations, forged in slow battles beneath our feet. The Himalayas may tower as the greatest symbol of this process, but every mountain range has its own tale of collision and uplift, its own chapter in the restless history of Earth. When we gaze at the mountains, we are looking at the frozen moment of impact, the crust the Earth caught in the act of reshaping itself. And as the sun sets on their peaks, glowing with colors that shift by the hour, it is worth remembering that they are still rising, still changing, still writing their story in stone. Mountains are not simply there, they are becoming, and in their becoming lies the wonder of a planet forever in motion. Of all the forces unleashed by tectonic restlessness, few capture human imagination or fear quite like earthquakes. Unlike the slow drift of continents or the gradual rise of mountains, earthquakes strike suddenly. One moment the world is calm, the next it shudders with violent motion. They are the most immediate reminder that the ground beneath us is not fixed, but alive with hidden tension. Earthquakes occur when stress builds along faults, the fractures where plates meet or where rocks within a plate shift against one another. For years, even centuries, pressure may accumulate as the plates lock together, refusing to move. But eventually the strain becomes too great. The rocks snap, slipping suddenly, and the energy stored in them is released as seismic waves that ripple through the earth. These waves shake the surface, rattling buildings, cracking roads, and toppling bridges. They roll outward like ripples on a pond, but with a force that can shatter entire cities. Some quakes are small, barely detectable by sensitive instruments. Others are catastrophic, leveling towns and reshaping landscapes in seconds. The San Francisco earthquake of 1906 tore through more than 400 kilometers of the San Andreas Fault, devastating the city and igniting fires that burned for days. The 2004 Indian Ocean earthquake, one of the most powerful ever recorded, lifted the seafloor by several meters, displacing vast amounts of water and triggering a tsunami that swept across coastlines from Indonesia to Africa, killing over 200,000 people. Japan, Chile, Mexico, Turkey, Nepal. The list of countries scarred by earthquakes is long. Anywhere plates grind, slip, or collide, the potential for seismic disaster lies waiting. And yet, earthquakes are not purely destructive. They are also essential to the restless balance of the earth. Without them, stress would build endlessly, tearing the crust in ways far more catastrophic. Each quake is a release, a resetting of tension that allows the plates to continue their slow journey. It is a harsh but necessary truth. The ground must sometimes break to keep the planet whole. Scientists measure earthquakes with seismographs, instruments that record the shaking of the ground. From these records, the magnitude of a quake is determined, once measured by the Richter scale, but now more commonly by the moment magnitude scale, which captures the total energy released. Small quakes of magnitude 2 or 3 happen every day, unnoticed by most people. Larger ones of magnitude 7 or 8 are rare but devastating, releasing energy equivalent to thousands of nuclear bombs. No matter the scale, each quake is part of the same restless story. Seismic waves also serve as a window into Earth's interior. As they travel through the planet, they bend, slow, or speed up depending on the material they pass through. From these patterns, scientists can map the hidden layers of the Earth, the crust, the mantle, and even the liquid outer core. In this way, earthquakes are not only reminders of danger, but also sources of knowledge, helping us see into the depths we cannot touch. Volcanoes, too, are children of tectonic motion. They rise where magma finds its way to the surface, whether along subduction zones, rifts, or hotspots. To stand before a volcano is to witness the earth breathing fire, exhaling heat from its hidden heart. Some volcanoes are gentle, spilling lava that creeps across the land like glowing rivers. Others are violent, erupting with explosive force that can darken skies and alter climates. Mount Vesuvius buried Pompeii in ash nearly 2,000 years ago, preserving the city in tragic detail. Krakatoa erupted in 1883 with a blast so loud it was heard thousands of kilometers away, triggering tsunamis and sending shockwaves around the globe. Mount St. Helens in 1980 blasted away, its summit in a cloud of ash and fury. Yet volcanoes are not only destructive, they build as well as destroy. The Hawaiian Islands, the Galapagos, Iceland, all are products of volcanic activity, land born from fire in the middle of the sea. Volcanic soils are among the most fertile on Earth, feeding millions with their richness. Gases released by volcanoes have shaped Earth's atmosphere over time, and eruptions have even influenced the course of history by altering harvests, economies, and societies. Earthquakes and volcanoes together are the most vivid evidence of plate tectonics at work. They remind us that the surface of our planet is not passive but active, restless, and alive. They bring awe as well as fear, destruction as well as creation. And though we often think of them as unpredictable disasters, they are in fact part of the steady, ancient processes that make Earth the planet it is. Every tremor, every eruption is a whisper of the deep mantle, a signal that the cycle of creation and renewal continues. In some cultures, earthquakes and volcanoes have been woven into myths, symbols of gods, angry or benevolent, forces beyond human control. In truth, they are neither wrathful nor kind. They are simply the earth, moving and reshaping itself as it always has. For those who live near faults or volcanoes, the reality is both humbling and inspiring. Cities like Tokyo, San Francisco, and Mexico City are built in places where the ground can shudder at any time. Communities near Vesuvius or Popocatépetl live in the shadow of mountains that may roar again. Yet people remain, drawn by fertile land, rich culture, or simply the pull of home. To live with earthquakes and volcanoes is to live with the knowledge that the ground itself is alive, and perhaps that is part of the beauty of our planet. Earth is not a static rock, but a world that breathes, shakes, and erupts. Its restlessness is the source of both peril and possibility. The reason why landscapes shift, why mountains rise, and why life itself has been given such diverse places to thrive. In the stillness of night, when the world seems quiet, remember that deep below, the planet is never truly still. The tremors and eruptions that sometimes break that quiet are not interruptions. They are reminders that we live on a world in motion, a world that reshapes itself with fire and quake, a world that, in its restlessness, has given us both challenge and wonder. The earth shakes, the earth erupts, and through these events it writes its restless story across the ages. Across Earth's long history, continents have not remained where they are today. They have wandered, collided, and drifted apart, reshaping the face of the planet again and again. This grand cycle of coming together and breaking apart is known as the supercontinent cycle, and it has played out several times over billions of years. The most famous of these supercontinents is Pangaea, the mighty landmass that existed about 300 million years ago. Its name means all Earth, and it was exactly that, a single, vast continent stretching from pole to pole, surrounded by a global ocean called Panthalassa. To imagine Pangaea is to imagine a world where today's continents were neighbors, pressed together in a giant jigsaw of land. North America nestled against Africa, South America tucked into the curve of West Africa, India attached to the edge of Antarctica, Australia snug against the side of Asia. Mountains rose along the seams where plates collided. Deserts spread across the interior where no ocean breezes could reach, and great rivers wound through landscapes that no longer exist. For millions of years, Pangaea dominated the planet, but it was not destined to last. Beneath it, the mantle churned restlessly, pulling at the great continent until it began to crack. About 200 million years ago, rifts opened and Pangaea started to split apart. The Atlantic Ocean was born, widening year by year as new crust formed at its center. India broke away and began its rapid journey north toward Asia. Antarctica drifted into the south. Wrapped in ice, the continents as we know them today are the children of that breakup. But Pangaea was not the first supercontinent, nor will it be the last. Before it came Rodinia, an older supercontinent that existed about 1 billion years ago. Rodinia eventually fragmented, giving rise to smaller continents that wandered the globe before reuniting again as Pangaea. Even earlier, scientists believe there was Nuna, sometimes called Columbia, a supercontinent more than 1.5 billion years old. And before that, there may have been even more ancient configurations, their traces faint and uncertain, buried deep in the rocks. The cycle is endless. Continents converge into one, break apart, drift across the globe, and one day come together again. Each cycle takes hundreds of millions of years, but the pattern is clear. If the past is any guide, the continents we know today are destined to reunite in the far future. Already, the slow drift of plates hints at new collisions to come. The Atlantic Ocean is widening, but the Pacific is shrinking. Australia is moving north, inching closer to Asia. Africa is creeping toward Europe, squeezing shut the Mediterranean Sea. One day, tens or even hundreds of millions of years from now, a new supercontinent will form. Scientists have speculated on what that future landmass might look like. Some imagine it forming where the Atlantic continues to open, pulling all the continents around into a ring. Others suggest the Pacific will close completely, bringing Asia and the Americas together. One proposed future supercontinent has been nicknamed Amasya, a giant landmass that would stretch across the northern hemisphere, uniting Asia with North America. Another scenario envisions Pangaea Proxima, a new version of Pangaea, where the Atlantic shuts and the continents reunite in familiar positions. Yet another idea imagines Novopangaea, a rearranged Earth where Australia merges with East Asia. Antarctica drifts northward, and the continents cluster around the equator. These visions differ, but they share a common truth. Earth's restlessness never stops. The surface is never fixed. The maps we know are only temporary. The continents may seem eternal, but they are travelers, wandering slowly across the globe, destined to meet and part in endless cycles. The supercontinent cycle has left deep marks on life, as well as on the land. When continents come together, oceans shrink, coastlines vanish, and climates change dramatically. The interior of a supercontinent can be dry and hostile, cut off from the moderating effects of the sea. Species are forced to adapt or vanish. When continents break apart, new oceans form, new coastlines appear, and ecosystems diversify. Isolation drives evolution, and fresh opportunities emerge for life to spread and change. The breakup of Pangaea, for example, opened pathways for dinosaurs to dominate the world, and later for mammals to evolve into diverse forms across separate continents. The cycle of supercontinents is thus not only a geological tale, but also a biological one. It has guided the course of evolution, shaped climates, and written the backdrop against which life has unfolded. When we look at a world map today, we are seeing just one frame in a film that stretches for billions of years. The continents are mid-journey, partway between past unions and future collisions. Our modern world, with its familiar outlines of Africa, Asia, the Americas, and Europe, is temporary. One day the map will be unrecognizable, with new oceans and mountains, new climates and coastlines. And just as we imagine Pangaea with wonder, some distant future species may one day look back at our world and marvel at how different it once was. There is a strange comfort in this perspective. The ground beneath us, though solid, is not permanent. It is a traveler in a cycle older than life, older even than the mountains and seas we know. To think of continents drifting endlessly across the ages is to see Earth not as fixed but as alive, reshaping itself in patterns too vast for human time. Pangaea rose and fell, Rodinia rose and fell, and the continents we know now will also rise and fall, bound to the rhythm of the supercontinent cycle. It is the heartbeat of geology, slow but steady, marking the passage of time not in years but in eons. The restless earth has shaped not only the land and seas, but also the story of life itself. From the earliest microbes to the rise of humanity, tectonic motion has been a quiet but decisive force, guiding evolution in ways both subtle and profound. Without drifting plates, the history of life might have unfolded very differently. Consider the early oceans, where life first began. Hydrothermal vents along mid-ocean ridges may have provided the chemical energy needed for the first cells to emerge. In those dark, mineral-rich waters, tiny organisms harnessed energy not from sunlight, but from the Earth's inner heat. These strange ecosystems, thriving in the shadows of tectonic restlessness, may hold the key to the origin of life itself. As continents formed and broke apart, the changing geography reshaped habitats, climates, and migration routes. When Pangaea existed, much of the interior was arid and harsh, limiting biodiversity. But when it split apart, new coastlines appeared, shallow seas spread across the land, and ecosystems flourished in the fresh diversity of environments. Species once united were separated by oceans, evolving along different paths. Isolation drove speciation, and speciation drove the explosion of life's variety. Dinosaurs, mammals, birds, and flowering plants all rose to prominence in worlds shaped by drifting continents. The collision of India with Asia, which raised the Himalayas, also changed global climate patterns, intensifying monsoons and creating new niches for life. The rise of the Andes influenced rainfall in South America, altering the Amazon basin and helping shape one of the richest ecosystems on Earth. Volcanic eruptions linked to tectonics have also altered the course of evolution. The vast lava flows of the Siberian traps, unleashed 250 million years ago, spewed gases that poisoned the atmosphere and oceans, contributing to the greatest mass extinction in Earth's history. More than 90% of species vanished in that Permian-Triassic catastrophe. Later, the eruptions of the Deccan Traps in India may have weakened ecosystems just before an asteroid struck, together ending the reign of the dinosaurs. These cataclysms, though devastating, cleared the stage for new forms of life. Mammals, once small and overshadowed, found opportunity in the absence of dinosaurs, eventually giving rise to the diversity of species we see today, including ourselves. Tectonics has also influenced the spread of humans. The formation of land bridges, such as the one that once connected Siberia to Alaska, allowed our ancestors to migrate across continents. The uplift of mountains and the creation of fertile valleys shaped where civilizations could thrive. The Nile, the Indus, the Yangtze, the Andes, each river and region owes part of its character to tectonic motion that guided the flow of water and the richness of soil. Even earthquakes and volcanoes have left their mark on human culture. Ancient myths often reflect the power of the ground beneath, portraying earthquakes as the footsteps of gods or volcanoes as the anger of spirits. These stories, born of fear and wonder, are echoes of humanity's long awareness that the earth is never truly still. To live on this planet is to live with its restlessness. Yet it is that very restlessness that made life possible and gave it room to flourish. Without tectonics, there might be no mountains to influence rainfall, no volcanoes to refresh the atmosphere, no continents to split and rejoin. Driving evolution forward, we owe our existence to the slow dance of plates and the deep breathing of the mantle. Life is not separate from geology, but entwined with it, written into the same story of creation and change. Even now, the restless earth continues to shape our future. Rising mountains alter weather patterns, volcanic eruptions affect global temperatures, and earthquakes remind us of our vulnerability. The continents are still moving, the oceans still opening and closing, the deep engine still turning. The stage on which life plays its story is never the same from one act to the next. For humanity, this brings both challenge and opportunity. We build cities near faults and volcanoes, accepting risk for the richness of the land. We study seismic waves and volcanic gases, seeking to predict the unpredictable. And in doing so, we acknowledge that our fate is tied to the forces beneath. It is humbling to realize that the ground we walk on, the mountains we climb, and the valleys we farm are all temporary expressions of deep emotion. They are chapters in a book still being written, shaped by processes that will continue long after we are gone. The restless earth has guided the history of life for billions of years. It has tested species with extinctions and rewarded them with opportunities. It has sculpted the landscapes that cradle ecosystems and civilizations alike, and it will continue to do so, carrying the story of life into the future. To see ourselves in this context is to understand that we are part of a vast, ongoing process, not the final chapter, but one more thread in the tapestry of time. The continents will keep drifting, the mountains will keep rising, the oceans will keep opening and closing, and life, in all its resilience, will adapt to the ever-changing stage set by the Earth's restless heart. The restless Earth is not only a scientific truth, but also a human experience. For as long as people have lived, they have felt the ground tremble, seen mountains rise, and watched volcanoes erupt. Long before plate tectonics was understood, our ancestors wove these phenomena into their stories, myths, and beliefs. To them, the Earth's motions were not mechanical but spiritual, the actions of gods, spirits, or ancestors shaping the world around them. In Japan, earthquakes were once believed to be caused by a giant catfish named Namazu thrashing beneath the land. In Polynesia, volcanoes were seen as the work of deities like Pele, the goddess of fire, who created new land with her eruptions. Among the Greeks, Poseidon was called the Earthshaker, a god whose anger could send tremors through the ground. Across the Americas, stories told of mountains that were once alive, of spirits sleeping beneath the earth, of fire that marked divine presence. These myths were not ignorance, but attempts to explain a world that seemed unpredictable and immense. They gave meaning to events that could otherwise seem terrifying. Even today, in places where earthquakes or volcanoes are part of life, culture and tradition carry echoes of these ancient understandings. Science has replaced myth with measurement and theory, yet the awe remains. Standing before a volcano, watching molten rock flow as though the earth itself were bleeding light, it is hard not to feel something sacred. Hearing the rumble of an earthquake or seeing a mountain peak piercing the clouds, one can still sense why early people imagined gods at work. The restless earth speaks not only to our intellect, but also to our imagination. It shapes not only the land, but also the way we think about our place in the universe. There is humility in recognizing that the ground beneath us can shake without warning, that mountains can rise higher than we can climb, that oceans can open wider than we can cross. These truths remind us that we are small in comparison to the planet we inhabit, that our time is brief against the vastness of geological ages. Yet there is also wonder. To know that continents wander like travelers, that mountains are still rising, that oceans are still opening, is to see the earth as alive. Not a static stage for human life, but a dynamic partner in the story of existence. This perspective deepens both science and spirit. It invites us to see geology not as dry facts, but as poetry written in stone. To view tectonic motion not as cold mechanics, but as the slow heartbeat of the planet. Every earthquake, every eruption, every mountain and ocean is part of this living rhythm. And though it sometimes brings fear, it also brings beauty, renewal, and the reminder that change is the nature of all things. The restless earth has shaped not only ecosystems and climates, but also the cultures and imaginations of humanity. It has taught us resilience in the face of disaster, creativity in explaining the unknown, and reverence for forces beyond our control in this way. Science and myth are not enemies, but companions, each expressing in its own language the truth that the earth is alive with motion. One speaks in measurements, the other in stories. Both are born of wonder. When we see a volcano glowing against the night sky, or feel the ground tremble underfoot, we are connected not only to the deep processes of geology, but also to the countless generations who stood before us, looking with the same mix of fear and awe. The Earth's restlessness is as much a human inheritance as it is a planetary fact. And as long as we live on this shifting, changing world, we will continue to tell its stories in myths, in science, in poems, and in dreams. For to be human is to dwell on a planet that never sleeps, a planet always becoming. The restless earth reminds us that permanence is an illusion. Mountains rise but will one day crumble. Oceans open but will one day close. Continents drift apart but will one day rejoin. Nothing stands still, not the land, not the sea, not even life itself. This truth, though daunting, is also comforting. It means that change is natural, that endings are beginnings, that what seems lost is often remade in another form. For humanity, this perspective can be grounding. Our lives are brief, our civilizations fleeting, yet we are part of a story billions of years in the making. The mountains we admire, the rivers we cross, the coasts we inhabit are temporary chapters, but they are chapters in a book that continues without end. To walk on the earth is to walk on something ancient and young at the same time, something steady and restless, enduring and changing. The restless earth is not a problem to solve, but a reality to embrace. It is the source of challenges, yes, earthquakes, eruptions, and disasters. But it is also the source of landscapes, climates, and fertile soils that sustain us. It is the reason our planet is alive, diverse, and beautiful. To live here is to accept the motion, to adapt to it, and to marvel at it. As you listen to the quiet hum of this story, perhaps preparing to drift into sleep, let yourself imagine the slow dance of countenance, the deep currents of the mantle, the rise of mountains, and the opening of oceans. Let the scale of it soothe you, the thought that even as you rest, the earth continues its patient work, moving in rhythms too vast for worry. For the restless earth does not ask for fear. It asks only for recognition, for the quiet respect due to something both fragile and powerful, both eternal and ever-changing. In its restlessness, we find not only science, but wisdom, not only motion, but meaning. When we step back and look at the whole story, from the fiery birth of the earth to the drifting of continents, from the rise of mountains to the tremble of quakes, we see a planet that is never still. The restless earth is more than a scientific curiosity. It is the foundation of the world we know. Without tectonic motion, there would be no mountains to guide rivers, no fertile soils enriched by volcanic ash, no oceans cycling nutrients, no climates shaped by rising ranges. Without the recycling of crust, carbon would not move between Earth and atmosphere, and life might never have flourished. The planet's restlessness is the reason it is alive. It is the reason we are here to wonder about it. Other worlds in our solar system tell us what Earth might look like without such restlessness. Mars, once volcanically active, now sits silent, its mountains frozen in time, its surface unchanged for eons. Venus, though shrouded in clouds, bears scars of catastrophic resurfacing events rather than steady renewal. The Moon, with its pockmarked face, has not changed much in billions of years. In their silence lies a stark contrast. Planets without tectonics are planets without the same balance of renewal. Earth is different. Its plates drift like rafts, colliding, breaking, creating, and consuming. Its mantle breathes heat upward, recycling stone into fire and back again. Its surface is sculpted, not once, but endlessly. And in that endless motion lies the chance for life, for diversity, for change. To see Earth as restless is to see it as alive. The science of plate tectonics has given us more than explanations. It has given us a new way to view our place on this planet. Once we thought the continents were fixed, the oceans eternal. Now we know they are travelers, temporary arrangements on a surface that shifts beneath them. This knowledge humbles us, reminding us that what we call permanent is fleeting in the scale of deep time. Yet it also enriches us. It allows us to read the language of rocks and landscapes, to trace the story of past oceans, vanished mountains, and future collisions. It connects earthquakes and volcanoes, ridges and trenches, into one grand framework. It turns what once seemed chaotic into a coherent tale of motion and renewal. The restless Earth has been at work for billions of years, and it will continue long after us. Our mountains, our valleys, our coasts, are moments in a story still unfolding. Our civilizations are brief chapters in the book of geology. Yet, in our briefness, we have been given the gift of understanding, the chance to glimpse the vast processes that shape our home. That perspective is as beautiful as it is humbling. So, as we come to the end of this journey, let us return to the quiet thought we began with. The earth beneath your feet is not still. It is drifting, colliding, rising, and sinking. It is restless, but not in haste. Its motions are slower than our lives, slower than our civilizations, slower even than the rise and fall of species. But they are steady, patient, and unstoppable. In that patience lies a lesson. We are part of a world that teaches us the power of slow change, of balance between creation and destruction, of renewal born from motion. Mountains rise only to be worn down. Oceans open only to close again. Continents wander only to reunite. Nothing is lost, only transformed as you drift now toward rest. Let that thought settle with you. The ground you lie upon is not still, but its restlessness is gentle on the scale of human time. You are safe in its slowness, rocked not by sudden fury but by the deep, steady rhythms of a planet alive. The restless Earth will keep moving, keep breathing, keep shaping itself for billions of years to come. And as it does, it carries us with it, travelers on a journey we can scarcely comprehend, passengers on a world forever becoming. The restless Earth is not something to fear. It is something to marvel at, to respect, and to hold in quiet wonder. For in its endless motion lies the beauty of our home, the stage of our lives, the story of all that was and all that will be. Good night. May the steady heartbeat of the planet beneath you bring calm to your own. May the mountains, the seas, and the drifting continents remind you that change is the essence of existence. And may the restless Earth, in all its patience, be a gentle companion as you drift into sleep.